Okay, cubic functions, calculus grade 12 maths. This is question 10 from paper 1 from DBE. The question is from November 2021. This is the question 10 from November 2021. You have 4 questions to solve and the total is 15 marks. Okay, let's get started on the next slide. Okay, let me get the question again. Question 10 from November 2021. Okay, this is the question 10 from November 2021. Okay, so you can see question 10 from November 2021. The graph of h of x is equal to ax cubed plus bx squared is drawn. Okay, the graph has turning point at the origin, that is point O, and as turning point at point B. Okay, so you are given the coordinate of point O and the coordinate of point B. Okay, A is an x-intercept of h. Okay, so you can see this is the graph of h. You have the turning point at point O and the turning point at point B. Okay, A is an x-intercept of h. So now question 10.1. Show that A is equal to -1 and B is equal to 6. This question is 5 marks. Okay, so you have 2 unknowns. Okay, you can see this is the equation of h of x. You have ax cubed plus bx squared. You have 2 unknowns. Because you have 2 unknowns, you need to create at least 2 equations so that you can solve for the 2 unknowns. Okay, the 2 unknowns are A and B. Okay, so we can use point on the graph of h to create 2 equations. Let's use points on the graph of h to create those 2 equations. So we can use this point B. You have the coordinate of point B, 4 and 32. We can use this point to create our first equation. Okay, so 4 is your x coordinate and 32 is your y coordinate. Okay, the equation is this: h of x is equal to this. Okay, so h of x is y, so it's going to be 32. Okay, this is equal to a, x is 4, so you have 4 to the power of 3 plus b, x is 4, right? So you have x to the power of 2. Okay, so let's carry on. This is 32 is equal to, you have 4 to the power of 3. This is 64 times a. Okay, so you are going to have 64a. You have 4 to the power of 2. This is 16. So you are going to have 16b. Okay, plus 16b. You can divide by 16 throughout. Okay, if you want. So you divide by 16, you are going to have 2. This is equal to, you divide by 16, you are going to have 4a, right? You divide by 16, you are going to have b. Okay, when you divide by 16 throughout, you have this. Okay, now we have this as our first equation. Okay, this is our first equation. Let's create our second equation. We can't use this point to create our second equation because the coordinate of this point, both x and y, are equal to 0. So it's not going to help us to create our second equation. Okay, so we need another point to create our second equations. So what we can do is to still use this point. At the turning point h prime of x, the first derivative at the turning point is equal to 0. So let's get the first derivative of h of x. Okay, so you have h of x is equal to this. The first derivative, h prime of x, is equal to, you have the coefficient is a and the exponent is 3, right? And here you have the coefficient is b and the exponent is 2. So you need to take the first derivative of this. You're going to have the exponent times the coefficient, and then you subtract 1 from the exponent. You also are going to have the exponent times the coefficient, and you subtract 1 from the exponent. You are going to get this. Okay, I hope you know how to get the derivative. Okay, so h prime of x is equal to this. Okay, So at the turning point, the first derivative is equal to 0. So h prime of x at the turning point is equal to 0. Okay, not 32, but 0. Remember that the first derivative at the turning point is always equal to 0. Okay, 32 is h of x, but h prime of x is equal to 0 at the turning point. Okay, so this is equal to, you have 3a and x is equal to 4, still 4, right? So your x is 4, you have 4 squared plus 2b, x is 4. We carry on, you have 0 is equal to, this is 16 times 3 is 48. Now you have 48a plus, you have 4 times 2, which is 8. You have 8b. You can divide by 8 throughout to simplify this. So you are going to have 0 divided by 8, it's 0. This is equal to 48 divided by 8, it's 6. Okay, so you have 6a, and you divide by 8, you are going to have plus b. Okay, you get this when you divide by 8 throughout. So this is our second equation. Now, from here, what you can do is to make a or b the subject of the formula. You can use equation number 1 or equation number 2. Okay, let me go for the simplest one. So I can use equation number 2. I can say b is equal to negative 6a. Okay, so I can say from equation number 2, b is equal to negative 6a. And this is my equation number 3. Okay, so what you can do is to take equation number 3, you plug it inside equation number 1. Do not plug it inside equation number 2, because equation number 3 is obtained from equation number 2. You cannot take it and plug inside 2. It's not going to help you. You have to plug it into another equation, which is equation number 1. Okay, so 3, equation number 3 into equation number 1. Okay, not 2, but number 1. Okay, so you have, this is number 1. This is 2 is equal to 4a plus b. B is equal to negative 6a. Your b is equal to negative 6a. This is equal to 4a minus 6a. This is equal to negative 2a. And so you have 2 is equal to negative 2a. Okay, 2 is equal to negative 2a. This is what you have. Okay, so what is a equal to? You need to divide by negative 2 on both sides so that you can solve for a. You divide by negative 2, you have a is equal to, you divide by negative 2, you have negative 1. Okay, and what is b equal to? You can use this equation to solve for b. b is equal to negative 6 times a is negative 1. So you have negative 6 times negative 1. This is equal to 6. Okay, let's carry on. Let me draw a line here. And now it's question 10.2. Okay, let me do this. Can do this. Okay, 10.2. Calculate the coordinate of A. This question is 3 marks. A, the point A is what? Is the x-intercept. Okay, you can see. So you know that to find the coordinate of the x-intercept, what you have to do is to let y equal to 0. You let y equal to 0 to find the coordinate of an x-intercept. So to get the x-intercept, you let y equal to 0. So this is your equation h of x. You have your a, which is negative 1, and your b, which is 6. Let's replace that. So you have h of x is equal to this. After replacing your a and b, a is negative 1 and b is 6. We have it, right? So you substitute your a and b. Now you have this equation. You can use this equation to get your x-intercept. Okay, let me close this for now. So to get the x-intercept, let y equal to 0. This is your y. H of x is y. You let it equal to 0. So you have this. right? Let's solve for x. Okay, so what is common in this? You can factorize x squared outside of the bracket. So you can take x squared outside of the bracket. You have this. You remain with 6 because you know 6 times this, you get this. And here you remain with negative x because you know that this times this, you get this. Okay, you close the bracket. This is equal to 0. Okay, so now you have x squared is equal to 0. What is x equal to? X is equal to 0. Okay, when you take the square root on both sides of the equal sign, you have x is equal to 0. Okay, you also have this bracket. This is equal to 0. Okay, so you have 6 minus x is equal to 0. What is x equal to? X is equal to 6. Okay, so you have x is equal to 0 and x is equal to 6. You can see from the question, you actually have two x-intercepts. Okay, you have two x-intercepts. So the first one, the x-coordinate is 0. And the second one, which is a, the x-coordinate is 6. Okay, so now the coordinate of a are going to be 6 and 0. Remember, at the x-intercept, y is equal to 0. Okay, so the coordinate of a, you have this. Now, it's question 10.3. Okay, question 10.3. This is the question. Okay, now it's question 10.3. Write down the values of x for which h is 10.3.1 increasing. Okay, the question is 2 marks. Okay, 10.3 and 10.3.1. Okay, write down the values of x for which h is increasing. Okay, when you check the graph, you can see the graph is increasing on this part only. So this is the part the graph is going up. So the graph is increasing on this part. On this part, the graph is decreasing. Okay, the graph is decreasing here and it's also decreasing here. Okay, only on this part, the graph is increasing. So it's going up only on this part. Okay, so from 0 to 4. Okay, the x coordinate is 4. So from 0 to 4, the graph is increasing. Okay, so you are going to say from 0 to 4, okay, the x values between 0 and 4. For these values, the graph is increasing. Okay, from 0 to 4, you have 4 there. Okay, or you can write in interval notation like this. X element of this interval from 0 to 4. So you can give your answer like this or like this. Okay, now question 10.3.2. Write down the values of x for which h is concave down. Okay, let's do this. Let's have the question here. So write down the values of x for which h is concave down. The question is 2 marks. Okay, 10.3.2. Where is the graph concave down? You can see the graph is concave up on this portion. After that, you have the graph is concave down. Okay, from concave up because it's facing up from here, and then to concave down because it's facing down. Okay, but somewhere you need to get your point of inflection. The point of inflection is the point where the graph is changing concavity. So you need to know the point of inflection so that you can give your answer. So to get the x-coordinate of the point of inflection, you can use this formula. Okay, the second derivative, you equate it to 0 and you solve for the x-coordinate. This x-coordinate will be the x-coordinate of the inflection point. Or you can use this formula. Since you know your turning point, this formula can be applied. So you have two options. You can use this or this to get the x-coordinate of the inflection point. Let me use this. So I'm going to use this. This is equal to the first x-coordinate of the turning point. This is your first turning point. So the first x-coordinate of the turning point, it's 0. You can see it's 0, right? So you have 0 plus the second x-coordinate of the turning point, it's 4, right? This is the second turning point. The second x-coordinate of the turning point is 4, right? So you have 4, you divide by 2. Now you have 0 plus 4, which is 4, divide by 2, which is 2. Okay, so this is 2. Now you have your x-coordinate of the inflection point, which is 2. So the inflection point is somewhere there. The x-coordinate will be 2 on the x-axis. So from 2 to positive infinity, the graph is concave down. The graph is facing down. So you are going to say for x greater than 2, you have all these values after 2. This is how you can give your answer. Or if you want, you can give your answer in interval notation. You can say x element of this interval from 2 to infinity, right? From 2 to infinity, the graph is concave down. Okay, so let's carry on. Now it's question 10.4. Okay, now question 10.4. 10.4. Let me get the question again. Okay, 10.4. This is the question. Now it's question 10.4. So 10.4, for which values of k will minus, in bracket you have x minus 1 cubed plus 6 times, in bracket you have x minus 1 squared minus k is equal to 0, have 1 negative and 2 distinct positive roots. The question is 3 marks. Okay, distinct means different. Okay, for which values of k will this have 1 negative and 2 different positive roots? Okay, so when you observe, when you check this equation and the equation of h of x, there is actually a translation that took place from this to this. There is a translation that took place. Okay, so let me write down the equations so that you can see what happened. So h of x is equal to this. You have your a is negative 1 and your b is 6. Okay, a is negative 1 and b is 6. You can see that. So this is h of x, this graph, and you have this graph, right? This is what you are given. You take negative k to the right. Now you have this is equal to k, a positive k, right? Negative k to the right, you have a positive k. So you can see the translation that took place. You can see instead of x, you have x minus 1, right? You still have your negative there, and you have cube there. So you have 6 there. Instead of x, you have x minus 1 squared. You still have squared. Okay, so the translation is that this graph is shifted 1 unit to the right to obtain this. Okay, remember when it is negative 1 in bracket like this, it is actually 1 unit to the right, not to the left, but 1 unit to the right. So this will be the graph of h of x minus 1. Okay, so h of x is shifted 1 unit to the right to get h of x minus 1. This is what we have. Okay, so let's try and sketch the two graphs on the same Cartesian plane so that you can see what is happening. So I can close this for now. So you have these two graphs. You have the graph of h and the graph of h of x minus 1 in red, this one. So you can see the translation from 0 to 1. Even here you can see from 6 to 7. Okay, so 1 unit to the right, you get this. So the question is focusing on the graph of h of x minus 1, the one in red, h of x minus 1. Okay, let me get rid of the one in black, h of x. Okay, so we remain with only this because the question is focusing on this. We don't need this. Okay, so we are going to test this. We are going to see this. Now, let's get back to the question. The question says, for which values of k will this, the one in red, have 1 negative and 2 distinct or 2 different positive roots? Okay, so 1 negative and 2 different positive roots. Remember that. 1 negative and 2 different positive roots. Okay, let's get our y-intercept. So the y-intercept is at 7. Okay, we can get that. To get the y-intercept, you let x equal to 0. So you're going to have 0 there and 0 there. Wherever you have x, you let x equal to 0 to get the y-intercept. So you're going to have this, right? X, you have 0 there. X there, you have 0 there. So this is equal to 7. This is equal to 7. as you can see on the graph is cutting the y-axis at 7. Okay, so this is your y-intercept. Okay, so we need this. Now, k is your y. We need to know the values of k, which will give us one negative root and two different positive roots. Okay, so to test k is y, we are going to use a horizontal line, which is cutting the y-axis. Okay, k is y, we are going to use a horizontal line, which is cutting the y-axis, because k is y. So when k is equal to 7, for example, you're going to have this. The value of k is 7, and you're going to have the line cutting the graph at this point, and at this point, and at this point. With this, you have a positive root there, right? This is a positive value. It is on the right side of the x-axis. So a positive value there, and another positive value there. Okay, distinct, meaning different. These are two different values, positive, but you don't have a negative root. You have a root which is 0, right? This is 0. So you have 0 and two distinct positive root. You need to have two distinct positive root and a negative root, right? But here you have 0. Okay, so you can see when it is below 7, when you test the value of k below 7, any value 6, 5, 4, 3, you're going to get 3 positive distinct roots. For example, let's say k is equal to 3, you're going to have this, right, at 3. So the line is going to cut the graph at this point, and at this point, and at this point. So you have a positive root there because it is on the positive side. Okay. And you also have another positive root there and another positive root there. So you have 3. 1, 2, 3. Okay. 3 distinct positive root. Okay. So this is not going to answer the question. You can see below 7, you're going to have 3 distinct positive root. What about a value of k above 7? Okay, so above 7, for example, we can use 30 there. So you have the line cutting the graph, right? Cutting this graph at this point, and at this point, and at this point. Remember, the turning point is there at 32, right? So we are testing 30. With this, you can get this root, which is a negative value, right? And you have this root, which is a positive value. And you have this root, which is a positive value there, right? So you have 2 distinct positive root and 1 negative root. So you can see when the value of k is above 7, you can have negative root, and you also have 2 positive distinct root. Okay, now the answer to this question will be k in between 7 to 32. This between 7 to 32, you can get 1 negative root and 2 distinct positive root. This is what they're asking you. For which values of k will this graph have 1 negative and 2 distinct positive roots? Okay, so between 7 and 32, you can see you have 1 negative and 2 distinct positive roots. Okay, so this is how you can answer this question. Or you can give your answer in interval notation like this: k element of this interval between 7 and 32. 7 and 32. Okay, 7 and 32. So this is how you can answer this question. I hope it's clear. I would like to see your comment in the comment section. Okay, for now, we are done with question 10 from November 2021. Until next time, I will talk to you soon.